on your homework yesterday, but it will happen. So, first, trying to get a common denominator on all of these terms, we start by factoring. And Vince, what can we factor this to? Correct. X minus 4 and x plus 3. Now, what do you notice happened? What could you guess that asterisk was about? Right. One of those is an x minus 4, and one of those is a 4 minus x. Not exactly the same, right? But easy enough to make them the same. Which one's order would you prefer to change around? 4 minus x is a little less common. So you're going to negate and negate. You're going to give a negative to both, and that'll flip that order. So before we jump into the rest of it, just to iron out what that does, the bottom is now x minus 4. That handles the negative on the bottom. And up top, we now have minus a negative 3, which will turn it to a plus 3. And now that that's ironed out, the rest of this problem is the same. What does this term need? X minus 4. I know you guys don't love to write x minus 4 twice, but some of you are forgetting to give that x minus 4 to the top. So write it out twice. The second one needs an x plus 3. And now we can drop, drop, drop. So we have a 2x minus 8 plus a 3x plus 9 equals a 2x minus 2. And that's a linear. And you just solve from there. And if a 4 comes up, or if a negative 3 comes up as an answer, we will reject that. But other than that, we're good. Okay, I'm going to stop there. If you jump down to 4, nothing crazy here, but after grading your quizzes yesterday, the only difference between this type of question is that these are monomial denominators instead of polynomial ones. So rather than having to factor anything, it really should be easier, but I realized yesterday on the test that I actually think we struggle more with monomial stuff than we do with polynomials, which is odd. It's different than what I'm used to. So I don't know if I taught something, said something differently this year that didn't sit well, but these 4 denominators, what would be the least common denominator of all of them? 10x squared. Do you see how this one has an x squared? Yeah. So this first one just needs an x squared. The next one needs a 10x. The next one needs a 2x. And the last one just needs a 10. So I like to just confirm. This would now be a 10x squared, that would be a 10x squared, that would be a 10x squared, and that would be a 10x squared. I just do those quick multiplications just to check myself one more time. And then up top, I've got x squared minus 10x equals 2x minus 20. Is that a linear, quadratic, or a radical? Quadratic. So you just would get it equal to 0. And solve, and what x values would we have to reject if they come up? Look at your original denominators. Which denominator, if x was negative 10, which denominator would be a 0 and would be a problem? Yeah, just 0. You're thinking if it was 10 or x plus 10 or something, but it's just 0 really is the only problem if it comes up. So if I go to solve this quadratic, subtract my 2x over and add my 20 over, factors pretty easily, does it? 2 and 10, yeah. X minus 2, X minus 10. So we have two answers, X equals 2 and X equals 10. That is something else that happened on the homework quiz. Some people factored, at least a couple people factored and stopped. They never actually solved it. They never actually wrote X equals whatever. And they never gave the solution. But they did all the hard work. Any questions on that? Monomial? Okay. Exercise 3 is just more of the same with monomial denominators. I want to go to the next one. This was on a Regents once, and it was very clear that some concepts were getting confused, and rightfully so. But this is a rational proof. And what's the two-step process for proving? Right, simplify the left, simplify the right, and then cross your fingers that they're equal, right? What do you make of the left-hand side? How would we simplify this? Maybe that's a trick question. Chloe? Like, how divide them out? Long division. Okay. I might go back. I'm gonna try that. I like that idea. If that's what your buddy said. I would have said this is already simplified. As far as being simplified, that is definitely like you can't cross anything out. You can't factor and cancel. You can factor the denominator, which is the sum of perfect cubes, but you can't factor the top, so nothing's gonna cancel. So simplifying to me means factor and cancel and it would be irrational. If you did do long division on the left, what would you put up here? 1, and then you multiply 1 by x cubed plus 8, and when you do your subtraction, what would you get? 1, and that's your remainder, right? So you do plus 1 over x cubed plus 8. So this division will give you this answer. So it would be 1 plus 1 over x cubed plus 8 equals 1 plus 1 over x cubed plus 8. And you would actually do that. Good work. I will tell you when we did this for yourself. Because the side that's easier to simplify and what resonates with most people is to simplify the addition, right? Actually add those two terms together. So if we're going to add these two terms, we need to get a common denominator. So I would actually do the work on the right side, and most people did. Give that an x cubed plus 8, give that an x cubed plus 8. And so up top, you'd have an x cubed plus 8 plus a 1 all over that common denominator of x cubed plus 8. And the left side didn't change. And then here's what people did wrong, because they were in the solving mindset as opposed to the simplifying mindset. They then, because they had a common denominator everywhere, they crossed them off. And they got it wrong because of that. Crossing off the common denominators, once you have that denominator on every single piece, is a solving technique. That's technically what you're doing, is multiplying by x cubed plus 8 on both sides. Anything you do to both sides is a solving technique. Only when you're solving can you drop the common denominator from everything and pay no attention to it. When you're simplifying, you always keep the denominator. So this would be x cubed plus 9 over x cubed plus 8. And then the left-hand side, we still have not really touched. We just continue to copy it down, and they equal each other. But a lot of kids ended up with x cubed plus 9 equals x cubed plus 9. And we had to take off a point. Because even though they obviously got the idea, they still used a solving technique. They did more than just simplifying. simplifying, you never drop the denominator. You only do that when you're solving. Does that make sense? Okay? I want everyone to do number 18 right now on your own. Lucas, do you have your homework that was due yesterday, the spiral and the homework? What was assigned on Friday? Raise your hand if you're done. Raise your hand if you're stuck. Oh. Where are we stuck? Let me see. Lucas, are you stuck too? You might all be at the same. That's all right. You might all be at the same spot. So let's kind of see what this irons out. Okay. I don't remember whose this is. But first step there. A plus 3 denominator, A plus 2 denominator, and no denominators to start. This person gave the first one a 2. So if you give this a 2, Bella, is this yours? If you give this a 2, what does this denominator become? 2a plus 6. You gave this one an a plus 6, And it doesn't look like you gave the top an A plus 6, but maybe you did without showing it. And you gave this one a 3, and what did this one become? So this one's a 2A plus 6, and this one's a 3A plus 6, and this one's an A plus 6. So they're not the same at all. You want very badly to be able to just change this 3 to the 2 or the 2 to the 3, but you actually, these are totally different. An A plus 2 and an A plus 3 is entirely different. There's nothing in common yet. This one needs the entire A plus 3, and this one needs the entire A plus 2, and this one needs an A plus 3 and an A plus 2. Does that make sense? Okay, take that. So this person gave this one an A plus 2, and again, they're not showing it, even though they're giving it technically to the numerator and the denominator, because if you don't give it to both, you're not technically multiplying by 1. Anyway, so this denominator became A plus 2, A plus 3, and we have that up top that we'll have to iron out. This one, they gave an A plus 3 and an A plus 2 on top. They only really wrote one of them on the bottom, even though I'm sure they did both. And this one, they gave an A plus 3 on the bottom, but it doesn't look like they did on the top. But maybe they did. You did. Okay. So A plus 2, A plus 3, A plus 2, A plus 3, A plus 2, A plus 3. We got it. So up top here, that multiplies out and is A squared minus 4. This one is tricky because there's a minus sign in front of all of this. So A plus 3, A plus 2 on its own is A squared plus 5A plus 6, but there's a negative sign out in front of that polynomial. So it should be a negative A squared, a negative 5A, and a minus 6, which is perfection. Good job, Lucas. Now I'm curious, where did he get stuck? Because that's the biggie right there, is that subtraction of a trinomial, making sure to distribute it. Was that you? And then on the right, he's got 3A plus 9. So far, it's perfect. Elena, I'll just give this back to you then if that was your issue. So that's perfect. And then now I'm very curious. So he's got, you subtracted your 3A over to get negative 8A. You subtracted a 9 over to get negative 19, and this just equals 0, and your A squared minus A squared is gone. And you got stuck? I think you probably got stuck because you thought it was a quadratic, but then the quadratic part canceled. And it's actually just a linear, so you just need to add 19 over and divide by negative 8. Add 19, and then maybe that got you tripped up if you visualize that because you didn't like that it wasn't a whole number. But that is the correct answer. You know how I can cheat and tell? Even though if these are open response, it's going to say solve algebraically. If you type this in as one side of your equation, and this side as another equation on your calculator, watch what I mean here. Oops. Okay, so one equation is x minus 2 over x plus 3 minus 1. That's the left side of the equation. The right side of the equation is 3 over x plus 2. Graph them, see where they cross. They should cross at negative 19/8, which looks like it's down there somewhere. So second trace intersect. See if it's down there somewhere. Negative 2.375 is where they cross. Guess what negative 19, negative 2.375 says the calculator. And if I check negative 19 divided by 8, negative 2.375. So you can always use your calculator to check if you're suspicious. Okay? It's a little tricky because the graph of it is pretty ugly. You know, rational graphs come in parts like this. So the left side was these two parts, and the right side was these two parts, and they only crossed really there. Okay? Nice job. Did I give you yours back yet? Okay. Before I hand out your homework, which is going to be your review sheet to start getting ready for Thursday, There was one question on yesterday's spiral that I looked at and I was concerned with, and that was the first one. So this is somebody's, and the instructions were to divide. Now, I realize that rationals are fresh on your mind, right? But x squared plus, and so factoring and canceling is a method of dividing and simplifying. That can do that for you. But x squared plus 9 is the sum of perfect squares, not the difference. So to factor it into, I think that says x, whoever says x plus 3, x minus 3, they factored it as if it was x squared minus 9.